Hi everybody, today we're looking at this sentence in the syllabus using using vectors to do proofs of geometric properties. And so very often it involves two things. So it is done using linear combination, so writing one vector as a sum of the addition of a couple of vectors, and it could be those vectors increase in size or decrease in size. And also, we use the idea that two vectors are parallel if one can be written as a multiple of the other, just the other multiplied by a particular number. So, let's have a look at how we might do this. So, here I'm being asked to show that the line segment MN is parallel to the side AB, and it's a half of it. Now, we're using vectors here. So let's have the vector Mn and the vector AB. And so I'm going to start by writing AB as a sum of two other vectors. Well, that's the sum of AC plus CB. If I look at Mn, M is the midpoint of AC. So if I take my vector AC, Mn, well, we'll start with MC plus Cn. And then MC is half of AC because M is the midpoint. And Cn is half of CB. And so then I can take out a half as a common factor. There's rules which allow me to do that with vectors. So it's a half of AC plus CB. So it's a half, well, AC plus CB is just AB. So Mn is a half AB. So then 1 is just a scalar multiple of the other. So AB is equal, well, Mn rather, is equal to a half AB. That's with the vectors. Therefore, the line Mn must be equal to a half AB in terms of its length, and the lines are parallel. So when I write one vector as another vector times by a particular number, then those two vectors are parallel. So these are parallel, and one is half the length of the other. With this question, we've got a hexagon, and we've got to show that Mn is equal to 1.5 times AB. So there's Mn, here's AB. Now, the key to this question is that every triangle is an equilateral triangle, which means that all these sides, internal and forming the perimeter, are all equal. That's key. That's really key to our problem here. So we'll start by noting that. And how do I know it's equilateral? Well, this is 60 degrees in here because it's 360 divided by 6. So that's 60 degrees. And we've also got isosceles triangles showing that these two interior sides are equal. And so then because this top angle is 60 and it's an isosceles triangle, these bottom two angles also need to be 60. And how do I know that these two sides from the center out to the edge are equal? Well, it said it's a regular hexagon. So that means that all the sides are the same and the angles inside are the same as well. And so that all put together means that the line from the center out to the edge will be the same regardless of where it's drawn. Now, if that's the case, then FOBA, so I'll trace the edge, FOBA, so this shape here is a parallelogram, FOBA, and I know that because FO must be the same as AB, and BO, it must be the same as AF because all lengths are the same. We could also show that they're heading in the same direction by angles, but it's enough to assume that they are going in the same direction from the diagram and because it's a regular hexagon. So because of that, I can say that OB must be the same vector as FA, and FO must be the same vector as AB. And also, we can say that, so it's similar for OCBA. So OCBA is also a parallelogram such that OC is equal to AB. And so therefore FC is equal to FO plus OC, and both of those vectors were AB. So FC is equal to 2 lots of AB. So now that we've got FC one way, let's get FC involving MN, because maybe we then could equate them. So FC, if I start at F, I'm going up to M, so that's FM plus MN plus NC. And so therefore I can say that 2 lots of AB is equal to FM plus MN plus NC. Now, FM and NC are a bit of a problem because they aren't, we don't want them. We want just an equation involving AB and MN. But if I look at FM, that's my vector here, well, it's half the length of OA. And they're also in the same direction. Now, if you need justification in that they're in the same direction, the angle here is 120 degrees, so the angle in here is 30 degrees. It's 30 degrees on the outer edges. And then if I draw a straight line up here, the vector AB is horizontal, so this vertical line is a right angle, and so then this angle here is at 30 degrees, and so both vectors are going up at 30 degrees out to the right of the horizontal, and so they're in the same direction. And the length of FM is half the length of AO. So FM is equal to AO in the same direction, and one is a half of the other. And then by a similar kind of idea, if I look at BO, well, and I might actually take it as OB, well, that's in the same direction as NC by a similar demonstration to how we showed the other one, and it will also be, NC will be half the length of OB. Now, why do I want to get that together? Well, if I just put them together, so if I have a half AO plus MN plus a half OB, and then we put the AO and the OB together, so that's 2AB is equal to a half AO plus a half OB plus MN. Then I can take the half out as a common factor, and I have AO plus OB. And if you go back to look at the diagram, AO plus OB is just the vector AB. And so from there, I can just do 2 lots of AB, take a half of AB, gives me 3 on 2 lots of AB is equal to MN. And so we've shown that. Okay, moving on with the next question. In a parallelogram PQRS, the points M and N are on the sides PQ and PS. Given that the point M divides the side PQ in the ratio 5 is to 2, so that's 5 lots, that's 2 lots. Find which ratio N has to divide side SP so that MN is parallel to QS. So we're assuming that MN is parallel to QS. Now I just realized I put the 5 and the 2 on the wrong side, so this is 5 and that's 2. So they're assuming that they're parallel, so Mn has to be equal to some number times by Qs. And Qs is equal to Qp plus Ps. While Mn is equal to Mp plus Pn. Now, Mp is 5/7 of Qp, because there are 5 out of the 7 lots that this has been, the side Qp has been divided into. So that's 5/7 of Qp plus Pn. Now, if I say this is divided in the ratio A to B, then I can say that Pn is A divided by A plus N lots of Ps. But we also need Mn to be some multiple times by Qs. So this is K times Qp plus K times by Ps. Now there's a couple of things, sorry, just before we keep going. So we can say this is K times Qp plus K times Qs. So I just want to make note of two things, which I'll do in red. So firstly here, that there is a rule, which we'll see later, which says the distributive law works for scalar multiplication. Of vectors. So by saying that K times Qs is equal to K times Qp plus K times, this should be Ps, from that we can then see that K has to be 5/7 by equating the first two vectors. And so then that means that A on A plus B must also be 5/7. And so then the ratio is going to be, so A is 5 and B is 2. So the ratio of Pn to Ns, well, they don't need to be the vectors, will be 5:2. Now, what's helping us say that is this idea that for every vector, there is only one linear combination of two or more vectors. That adds, well, we've got linear combinations, so I guess what that's saying is we can't get a different K for Qp and Ps adding to give us Mn. There's only one that works. And so the one that works is where K is 5/7. And so there's no other solutions, no other possible solutions for this one, which gives us confidence in our solution that we've got. Okay, alright, final question. In a triangle ABC, the midpoints LMN of the sides are given. Show that the medians, so AL, BM, and CN can form a triangle. Now the idea is that they'll form a triangle if they sum together to give 0. Now let's start by just looking at that. Like if I do CA, so let's take the triangle ABC, and I add that to AB, and then to that I add BC, I end up where I started, so this is equal to the 0 vector. And that's one of the ideas of a triangle. If the three sides sum to give us a zero vector, that means that they all must meet up, or you end up where you started, and so you've got a triangle. Okay, so let's have a look. Let's get our vectors AL for starters. So AL is from A to L, so it's equal to AB plus, now L is the midpoint of BC, so we only need half of BC. Okay, and then CN, or CN, is equal to CA plus half of AB. And then finally, BM is equal to BC plus half of CA. Now if I do AL plus CN plus BM, well, that's AB plus a half BC plus CA, this gets a little tedious, plus a half AB plus BC plus a half CA. Now let's look at what we've got common. So I will note I've got an AB here and an AB here. So I've got 1.5 ABs. So that'll be 3 on 2 AB. Then I've got half BC here and a BC here, so that'll be 3 on 2 lots of BC. And I've got a CA there and a half a CA there, so that'll be 3 lots of CA. So there's a common factor of 3 on 2. And we mentioned last time that we can use the idea of the distributive law with vectors. So I can factor out the 3 on 2 because it's just a scalar number. And then if I go back to the start, CA plus AB plus BC was a zero vector. So we've got 3 on 2 times a zero vector. And because the zero vector has zero magnitude and no direction, when we do 3 on 2 times the magnitude, we still just get 0. And so we've shown that they can form a triangle because they sum to the zero vector. Now, these questions in the textbook are probably less likely to be in the exam because they're very vague and open-ended. They don't give you a lot of direction. They're still good questions to work through and to practice because they ingrain the idea. But in class, we'll do one where it gives you a little bit more direction and guidance, and hopefully that might help you feel a bit more comfortable with this. But for the moment, we'll leave it there.